Okay, a little bit harder than yesterday's. We're still talking about functions, but we're talking about evaluation, which is getting an ordered pair, and we're also talking about domain and range, okay? So the very first thing that we're going to have is we are going to do the function rule. A function rule is an equation that represents y in terms of x. It's a very simple concept. It looks just like y equals mx plus b. There's a y and there's an x in it. Stay focused with me today. Okay, so I have y equals negative 3x plus 6. That is a function rule. Y equals 2x minus 5. That is a function rule. If I plug in a value for x, I can chug out a value for y. Does that make sense? Okay, the next thing is called function notation. It is another way to represent mx plus b. What you're doing is you're eliminating the y and replacing y with f of x. It's formal notation. It's formal notation. It's no different than you referring to me as Mrs. Yoder rather than Kendra Yoder. Does that make sense? It is not appropriate for a student to call a teacher by their first name, which is why you say Mrs. Yoder. That is formal notation. Does that make sense? Same exact concept here. So if I give you y equals 2x plus 3, the function notation is f of x equals 2x plus 3. That's all you're doing. Do we understand, yay or nay? Okay, so write the equation y equals negative 9 plus 4x in function notation. What am I replacing? The y becomes an f of x, and I drop down everything else. Do we understand that, yes or no? It is that simple. It's the difference between me calling you Bland or Destiny rather than Mrs. Bland or Miss Bland. Yes, same exact thing. You're still yourself. Okay? Because it is. Move on. Okay, using function notation. It's used for evaluation of a function. Okay, it is used for evaluation of a function. Given f of x equals negative 2x plus 5, what is the output value for the inputs negative 3, 0, and 1/4? Now, what does input and output mean? Output is your y value, input is your x value, correct? Do we all understand that? Now, what that means is you are simply plugging and chugging. That's all you're doing. You're plugging and chugging. Okay? So let's do that. I give you the function f of x equals negative 2x plus 5, and I want to know what f at negative 3 is. So I'm going to replace x with negative 3. So what's negative 2 times negative 3? Plus 5? 11. So I give you this, and I want you to write it as an ordered pair. So what is my ordered pair? Negative 3, comma 11. Do we understand that? Negative 3, comma 11. Are we good? Okay, same exact concept for the next one. I want to do f at 0. So what am I going to do there? Negative 2 times 0 plus 5. That's going to give me a 5. So what is my ordered pair? 0, comma 5. Yes? 0, comma 5. Okay. Now, with that being said, I need to do f at 1/4. If I'm doing f at 1/4, I'm going to do exactly the same concept. So I'm going to have negative 2 times a 4th plus a 5. What is negative 2 times a 4th? Say that one more time. Negative 1/2. You owe me 50 cents and you have $5. What is your change? 4.5, which is the same thing as 2 times 4 is 8 plus 1 is 9 over 2. Yes? I went from a mixed fraction to an improper fraction, correct? So what is that ordered pair? 1/4, comma 9 over 2. Do we all understand how to do these three problems that I just talked about? This is how you are going to do problems 1 through 8 on the homework. Do we get that? Plug in a value for x, chug out a value for y, write it as an ordered pair. Any questions on 1 through 8? X will always be what you plug in for the function f of x. Okay? I'm going to skip the next page, and then I'm going to go through this page right here of interval notation. Now, what we're going to talk about right now is going to be domain and range. As soon as I talk about domain and range, we need to understand there's two different ways to write domain and range notation. The first way is talking about interval notation. Interval is exactly that. An interval is a starting point and an ending point. Does that make sense? And it's an interval at which something happens. So it is an ordered pair is what it looks like, and it is going to have a starting point and an ending point. Where am I starting at and where am I ending at? The problem is you can have parentheses or brackets. How do I know which I use? Parentheses means it excludes the value, so you're using less than or greater than symbols. Remember the open dot versus closed dot concept? An open dot excluded? This is kind of like that. So this is where we're going to have the open dot concept. Okay? Then a bracket means it includes it, so it's going to be less than or equal to or greater than equal to. And that means it's the closed dot concept that we used previously. Do we all understand that? Remember whenever I gave you these number lines and it was either an and or an or you had to write the inequality? That's what I'm talking about here, okay? Now, an example of this is going to be -3 is less than x, which is less than or equal to 7. The starting point is at -3. See how -3 is the starting point? That's why I have -3 there. Why do I have a parenthesis at -3? Well, I have a parenthesis because it says strictly less than. Make sense? Then I'm ending at 7, but my symbol for 7 is less than or equal to, meaning it can be that, which is why I have a bracket. So let's do it one more time. -2 is less than x, less than or equal to x, which is less than 4. So where am I starting this at? -2. Can it be -2? So is it a bracket or a parenthesis? It is a bracket, comma. Where's my ending point? 4. Can it be the value 4? So do I have a bracket or parenthesis? Parenthesis. That's as simple as I can get on that. Okay? Now, the largest number in the world is going to be infinity, and the smallest number in the world is going to be negative infinity. Do we all understand that? How do I write infinity symbols? It is a sideways 8. Do we all understand that? It is a sideways 8. We good? Yes? All right, that is interval notation. Maybe. Okay, set notation. Set notation has to have braces. If you do not have braces, you are not in set notation. So you cannot forget the braces here. Now, if I come up to Cole and say, Cole, you look so familiar. How am I going to get to know how I know him from? What would he use to describe where he's from? First, he would probably say a town and be like, no, I've never been there, but, you know, what about this? Then what's the next thing he's going to use to describe himself? His parents or his family. Does that make sense? He's going to describe himself to being a part of a family. That is the same way as the number system. So you have to put the number system inside a family. The number system we are always going to be using is the real number system. How do you draw that symbol? 2 lines down and make an R out of it. You with me? Now, your letter X, or it could be Y. Why am I X or Y? What does X stand for? Input, which is the same thing as domain. And what does Y stand for? Range. Do we understand that? So depending upon what I'm talking about, depends upon which letter you're going to utilize. Okay? Now, here's the kicker. The brace is there. Then I'm going to say X is an element of the reals. That element symbol is a curved E. One more time. The element symbol is a curved E. It is simply making a C and putting an extra line into it. That says I am a member of the real number system. Make sense? The bar right here is going to be the such that. and then you're going to give me an inequality for the restrictions. So x can be any number as long as x is greater than or equal to 5. X can be any real number as long as it's negative 10 is less than or equal to x, which is less than 8. Now, how do I write these two things right here in interval notation? How do I write x is greater than or equal to 5? Well, if x is greater than or equal to 5, here's 5. Would you agree with me? Is it opened or closed at 5? Closed, and where is x going to be? To the right of it or to the left of it? To the right. So, with that being said, I have a starting point and then an ending point. What is my starting point for this graph? It is 5. Can it be 5? Yes. So do I have a bracket or a parenthesis? I have a bracket. And where do I stop shading? I never stop shading, so it goes all the way to infinity, which is why I'm going to use the infinity symbol. And then you always put a parenthesis there. Do we understand that? That is what the first one will be, right here. That's what this is. Okay? Starting point and ending point. Okay? Now, this one right here. How do I graph that? That's going to be negative 10 and 8, closed here, open here, and I'm shading in between. Yes? So what is my starting point? Negative 10. Can it be negative 10? So I have a bracket. And then where am I going to? Positive 8. And can it be 8? Parenthesis. That is the interval notation of that. Opened or closed dot. Less than or equal to or strictly less than. I already used those symbols over here whenever we talked about that. Right here. Brackets, parentheses. Less than, greater, less than or equal to. Okay? If it has this symbol right here, then you have to use brackets. If it has one of these two symbols, then you have to use parentheses. So if we go back to our example here, it had the less than or equal to symbol, which meant bracket. This had the less than symbol, which meant parenthesis. Okay? All right, now, these two slides right here simply tell you in words how to find the domain and the range. Now, we are going to do this together. Whenever I said domain yesterday, I said that domain is read from which direction? Left to right, from the smallest number in the world that x can be to the largest number in the world that x can be. How did I say range was read? From bottom, the smallest y value, to the largest y value. Do you remember that? Yes? So, what we're going to do is we are going to look at these graphs right here. And I want you to find the domain and the range using set and interval notation. Are you ready? So, here we go. The very first thing I want your brain to say is, okay, domain. What letter deals with domain? X. And how do we read this? From left to right. So if I'm reading this from left to right, the very next thing I want to do is look for arrows. What do those arrows mean? The arrows mean that they go off the graph, off the paper, off my board, into the ceiling, through the roof, into the sky, and into outer space. Would you agree with me? It goes on forever and ever and ever. Those arrows mean that it is going to go all the way over here, clear over here on the left side of my x-axis, and it's going to go clear over here on the right side of my x-axis, being positive. That means it's going from negative infinity to where? Positive infinity. So interval notation is going to be from negative infinity to positive infinity. Do we understand that, yes or no? Yes? That is interval notation. Now, how do I describe that as set notation? Set notation has to have a brace. Then we use the letter that corresponds with the word. What word am I talking about today? Domain. And what letter corresponds with domain? X. So X, and then I put it in its family, is an element of the reals always. And then I put any of the domain restrictions. Do I have any domain restrictions? No, so I simply close the brace. Does that make sense? What X cannot be. Range. How do I read range? From bottom to top. Now, I am going to be literally, I'm going to use my lovely little blind here. Okay, do you see this line? My blind, I'm approaching, when do I first run into my graph? At what Y value? 0. Did you see that? I ran into it at 0. So if I run into it at 0, when do I stop running into it? I never stop running into it because it's going to go on forever and ever and ever and ever, so that's going to go all the way to infinity. Now here's my question. I know infinity has a comma, or I should say has a parenthesis, but what about 0? What does 0 have? Does it have a parenthesis or a bracket? Can it be 0? Yes, so I have a bracket. Do we understand that? Yes? So with that being said, the next thing I want to do is set notation. How do I do set notation to describe this region? I'm going to go ahead and put a brace. And what letter corresponds with range? Y is an element of the reals such that. Now, how would I describe the range? Y can be any value as long as what? As long as it is what? Y is greater than or equal to 0, close your brace. Y deals with the range, which is why you have to use that letter. Are you in English right now? Okay. Do we understand this, yes or no? Did you tell your lab teacher? Okay, next. Mitchell, here. Okay, same exact thing. Domain. What letter deals with domain? X. So I'm chugging along here. And I'm going to go ahead. I'm chugging along here. And where do I first run in to my graph? At what value? The X value that I run into it at is going to be -3. Can it be -3? Yes. So do I have bracket or parenthesis? Bracket. Comma. When do I stop running into it? At +3. Can it be it? Yes, because I see part of a graph, so that's why it's a bracket. Gavin, what's the set notation? Yes, that's what that says right there. Now, how do I write that as set notation? Stay awake. How do I write set notation? What do I do first? I have to have my brace. Then what letter deals with domain? X. Put it in its family, such that. Now, how do I describe -3, to 3? This is your compound inequality. That's an and remember, an and is trapped. So how do I write that? -3. What is -3 compared to 3? Less than or equal to, because it's a bracket, X less than or equal to +3, and then close the brace. Got to remember the one section we did in class together a long time ago, right? Okay, now range. How do I read range? Bottom to top. So I'm chugging along here, and where do I run into my y-axis, the graph? At -1. Can it be -1? So bracket. Where do I stop running into it? At +1. And it can be that. So now how do I write the set notation? Cameron? Brace. It's okay. Range is Y. Element of a real number such that. less than or equal to y, which is less than or equal to 1. Good job. Do we understand that? Okay? We good? Okay, last one. Okay, I'm so sorry. I can back up. There you go. Whoo, deep breath back there. Are there any holes in this graph? So that means they're all solid dots. So every point that it lands on is a solid dot, and it can equal it. So you're going to use nothing but brackets here. You with me? Yes. Okay. Okay, here we go. What element or a member of? Okay. All right, here we go. Domain. Domain's what letter? X. Okay. So what do I notice on this problem? It is a line, but what else do you notice on that line? There's arrows. Those arrows mean that it goes on forever and ever in both directions, yes? Negative infinity to positive infinity. And the reason why is because the lowest x value is going to be negative infinity. The highest x value is positive infinity. Yes? I use parentheses because infinity always has to be parentheses. Okay? Now, how do I write this as domain? Brace. Brace. Brace x is an element of the reals such that, do I have any domain restrictions? So do I need a such that symbol? No, I simply put another brace. Do we understand why there's no bar there? If there was a restriction, there would be a bar. There's no restriction. That means x can be any number. There's no inequality symbol that you need to put there. Range. Range. How do I read range? From bottom to top. So look at this arrow. The arrow is going all the way to the bottom. What does that mean? Negative infinity. And then this arrow is going all the way to the top. So what's that mean? Positive infinity. So now what? Y is an element of the reals. Do I have any restrictions? No, so I simply close it. It doesn't have a starting point or ending point like this one had. Do you see how these all have points? It says my graph is only between -3 to +3. Those arrows mean that it goes on forever. Let me pass out tonight's homework. Quiet, please. I'll come back and help you individually, but I'm going to get everybody else started. Do I? Yes. I'll get it. Okay, quiet down. Problem number 1 through 8. You write it, plug and chug, and write it as an ordered pair. Problems 9 through 17. You are going to do domain and range exactly the way we did it in class. Okay, circle these problems. Problem 4, problem 7, problem 11, problem 14, and 17. I want you to do those problems with your table partner. If you do not have a table partner, scooch together until you have a table partner. Okay? Okay, the rest of the quiet. The rest of the period is yours to work If you are not working, I'm talking. If you speak and it's not about math, you lose your table partner and you will not be able to look at the answer key until tomorrow. Am I clear?